Okay, since we just introduced you to know the singular and ordinary point, here is the theory to use to define the meanings of singular and ordinary point. If you take a look at this differential equation, where a0, a1, and a2 are functions of x, it's not a constant, okay, it's a function of x. You do rearrange the differential equation in such a way that the coefficient in front of the second derivative of y is equal to 1. So you would get px is equal to a1 divided by a0, and your qx is equal to a2 divided by a0. It's saying that if x0 is an ordinary point of equation, start here, px and qx is an analytical function at x equal to x0. Any values of x make px and qx not to be an analytical function. Those x are singular points. That's the meaning of the singular point. So, but any x that makes px and qx to be an analytical function would be ordinary point. Now, let's take a look at the example. We have differential equation like this. So, we want to consider what is the singular point and what are the ordinary points. So, the way that we do is just that making the coefficients in front of the term of second derivative of y become 1. So, we would get px is equal to psi x divided by x, and qx is equal to 3 times x to the power 3. From this, you would say, oh, x is equal to 0 would be singular point of it, but actually it's not. Because this is psi x, this is x. You've got to use the summation form of psi x, replace it there. So you would see that no x down here, so that means any value of x are the ordinary point. So no singular point for this problem statement. Right? This one is every value of x is an ordinary point. But if you take a look at another example, we have differential equation like this. Now we are going to consider the value of x, which one are the ordinary points and which one are the singular points. The way that you do it is just that you're making the coefficients in front of the term of second derivative become 1, and then you would get px is equal to x divided by 2x, x minus 2 times x plus 1, and your qx is equal to x times x minus 2 times x plus 1. If you take a look at here, x equal to 2 and x equal to minus 1, making px is non-analytical function. So that means x equal to 2 and minus 1 is the single point. But if you take a look at qx, 1 over x times x minus 2 times x plus 1, you have 3 values of x, which is makes qx is not an analytical function. So that means with this problem statement, 0, 2, and minus 1 are singular points. The rest of x are ordinary points. Now you know the meanings of ordinary and singular point. Now, next is the theory that we are using when you find the solution. If x0 is an ordinary point of this differential equation, you can find the solution by assume y is equal to summation of n equals 0 to infinity of an times x minus x0 to the power n. This is, and then after you get the power series, you want to check whether your power series is converted in what range. You can find it from absolute value of x minus x0 is less than r. So that means it's going to convert within this range. If you take the absolute out, you would get, for example, if x0 is equal to 3, and if r, which is the radius of convergence, if r is equal to 1, for example, if we have the ordinary point is 3, and we have the radius of convergence is 1. So we want to know that the answer which is coming from our ordinary point is covered in what range of x. We would get, when you take the absolute out, you would get x minus 3 is in between minus 1 and 1. And then you solve for the solution, you would get x is between 2 and 4. So that means the x value of the solution that you can use is just covered in the range of 2 to 4.